In this little demo, we have a 12-volt power supply providing power to the brushless DC motor board, which is getting its control signals from an Arduino, and the Arduino is actually connected live to a PC, getting control signals from the processing PID program that's running on the PC. So again, what's happening is we have a PC running a little processing program. This is a PID controller. We'll look at that in more detail in just a minute. That PID controller is receiving signals from the Arduino about motor speed, and it's sending control signals back to the Arduino. Here's the Arduino again, and here's the motor board. Let's take a little closer look at a couple of things on the motor board, just a couple of cautions here, concerns. Number one, this particular motor board has pins that are close together. Here's the ground pin, here's the plus 12 volt supply pin on pin 2. Pin 3 is the PWM signals coming from the Arduino board. Caution, do not try to measure signals on these pins on the board, because if you do, there's too much of a risk to short out pin 2 and 3 on the board. What that does is sends 12 volts back to an Arduino digital input. This particular board has a blown out digital line. Port 3 is blown out because of the very reason I just mentioned. Someone was probing and accidentally connected 12 volts to the signal going back to the Arduino digital output. So just be careful with that. And in general, be careful with everything on the breadboarding with all wiring, and make sure nothing shorts out. So okay, enough about the board. What's it doing right now? We're going to go back and look at the PC and processing in just a minute, but what it's doing right now is spinning at, let's look at my set point over there. I don't know the actual speed, but the arbitrary set point is set to 700 out of 1023. So it's regulating the motor right now, which is spinning. This LED indicates the relative brightness of the drive signal. You'll notice sometimes it's getting dimmer and brighter as the drive signal, which ends up at the motor, is getting higher and lower, and that's again from the PID controller. So this board is sending motor speed signals to the Arduino board, back to the PC. Let's take a closer look at the PC now. What's going on over there? Okay, in the top screen of this processing PID controller, in the top screen we have a green line that represents the set point, and at this point we had changed the set point. We went from an arbitrary 500, I believe it was, up to the current setting of 700, and that step change was followed pretty well by the red line. The red line represents the actual motor speed. Okay, so the motor speed is all over the place, but right now it's fairly steady. This PID loop for sure needs some tuning, but for what we're working with a fairly simple motor board, this is pretty decent response. That speed is pretty well regulated. What's doing the regulation? Again, the PID signal that's coming from processing from the PC. What we see in the bottom window is that drive signal. This is going from 0 to 255, so it is changing the drive in response to the motor speed feedback that it's receiving. And if we look over here, we can possibly see this output signal right here. Again, this is the numeric representation of what's happening in the blue down here. This is the motor PWM drive signal changing, trying to maintain that speed constant. We have the PID terms over here on the left, and those can be changed to different values, as well as the set point being changed up here. So if we change the PID values, we can get better response from the PID loop. Right now, actually, this is a very good response for this motor and this hardware software setup. So there we had it, a simple demo of what we'll do in lab with PID control of a motor board.